Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 369. Maximum points after collecting coins from all nodes. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this farm. So this one can be way tricky. I think I don't know. I actually didn't catch it right away, but I don't know. I think this one can be tricky if you don't think about it in a very specific kind of way, but I was able to kind of notice that the key thing to notice is that well, first it's a tree and you can only start from the root, so there's no choices, right, with the nodes and stuff like that. So everything is just a depth first search in a way, but there is a decision to be made at every node, right? Sorry, there's like something going outside my window and it's a little bit distracting. I gotta stop looking at it. But yeah, but basically there's two decisions you can make at every node, which is obviously collect all the coins and get these points, or halving them, but with a repercussion of being the future, it'll reduce, right? So the naive thing to do, and I think that's the right direction, is just doing the recursion that way and keeping track of how many because if you think about the states, the states is going to be pretty straightforward, which is just the number of times you use this, right? Because you can think about it as divided by 2, then divided by 4, divided by 8, ... and you just keep track of, you could store it in a few ways, but that's basically the idea, right? Like, you could store it divided by 1, divided by 2, divided by 4, or you can just store the number of times you use this thingy. The tricky thing with that, and that's pretty much really 90% of the idea, but you're not going to get it right without 100% of an idea. And the core part of solving this is, or let me give you an example real quick, is that, all right, so let's say this first one, but let's say you have 1,000, right? So you have essentially a linked list of 1,000 elements. Then what happens? So I'm just going to, I'm not going to actually do 1,000 of these, but let's say you have a linked list that looks like this, and then your recursive structure is going to be something like, okay, so we could do 1 with 1 or 0, right? So that means that we could do 0 or 1, as in the number of times that we have halved, or use operation 2, let's just say, right? We have halved. We could do 0 or 1. What about the 2? Well, we could do 0, 1, or 2 because we could have half on the first 2. We could have on one of them, obviously, and also just none of them, which is also obvious. So 3 is going to be 1, 2, 3, ... right? I mean, and then now we can ... and 4, same idea, right? If I typed it correctly. And then now at 1,000, you can also imagine that now you could have once, have twice, have 3 times, have ... 1,000, right? So if you kind of sum up all these possible inputs, because then now our input is going to be used, right? The number of times we used operation 2, well, that's going to be n squared. It's 1,000 elements. It's going to be 0. It's a classic triangle. You have n squared over 2, right? Roughly speaking. So that's not going to be fast enough when n is 10 to the 5th. So what can you do? It turns out that you can actually look at the coins, right? Coins only goes to 10 to the 4. What does that mean? That means that after a certain amount of times, I think it's 14 or 15, everything after that becomes 0, right? Meaning that, and yeah, let's say it is 10,000. You have a 10,000 coin thing, a node. After you have it 15 times or whatever it is, it's just gonna be 0 no matter what. So that means that all these states that are bigger than 15 are the same, right? Because it means that everything after that is 0. In fact, you could, now that I think about it, you could actually just recurse. You could just end early. You don't even need to, because the way that I did is a little bit different. We'll play around with it afterwards. But you can, for now, you can say that everything after 15, it becomes 0. So then, that's what you get, right? So yeah. So, and what happens once you realize this? That means that you could compress everything down to 15. And that means that you have 15 times, or whatever it is, times 1,000, or in this case, 100,000. And that is going to be fast enough, right? Instead of 100,000 square, right? So that's basically the short idea behind this problem. And once you get that, it's pretty straightforward, somewhat, right? Here we convert the edge list to, or we convert the edge list to an adjacency list. And here we recurse on the root. We have the node, the parent, and the used. We'll go over the complexity in a second. We kind of already did, but yeah. And then here it's just if we, and coin is just the current number of coins divided by the number of times we used, or 2 to the number of times we used. So I just did a right shift. Here, this is how we calculate the tick, right? So we tick this one, which means that we take the negative k thing, then we sum up all the summations of that and keeping the same used. Otherwise, this is if we halved. If we halved, we divide it by 2, and then we again do a used plus 1 on the recursion, and then we take the max, and that's pretty much it. Yeah. I think that's pretty much it. So one thing that, let's do a quick analysis real quick. Node, of course, is 0 to 100,000, or n over, or n, which is 100,000. Parent can also go from 0 to n, and then use can go from, as we say now, 0 to 15 or 0 to 14, or either 15 or 14. I guess we technically go to 15 because I was a little bit lazy, but on the thing, but. Right, so then of course this is going to be O of n squared times 15, right? Oh no, of course not, because we only rooted once. We only have one root. The depth first search, if you think about how you construct the depth first search tree, it's always going to be deterministic. There's only one parent for each one, so that means that for each input node, it's going to always have the same parent. So this is not an extra dimension. It's just something to store. So that means that it's going to be 15 times n, which is going to be O of n. And you could also maybe say the 15 comes from the fact that the max number, let's say m, this is log m of that or something like this. So you could say log m, or if you like, I don't know. Time, right, and O of n space, or I guess log m space, if we're going to keep it consistent. And yeah, that's pretty much it. That's all I have for this one. I'm going to try something that I didn't realize yet, but I could even do something like if used. I think if used is equal to 15, we can just return 0. We don't even have to do the recursion, right? Because that means that everything on this tree and sub, I'm gonna just remove this just so that we don't have both. But maybe I could even just 16, so I'd be slightly more careful. It should be fine, and then we could give a submit. And hopefully that should be fast enough, and also correct. I mean, it may be fast, and looks like it's correct, so that's good. I'm just curious about the timing, and some of this is input independent anyway. So I guess it's about the same. It doesn't, at least for their inputs, it doesn't really change anything. So I don't know, but it is something to consider, I suppose. Should be faster, but I don't know. Maybe the inputs are just like not that messy. I guess everything gets cached after that. So you only do it once. I don't know. Anyway, yeah, that's all I have for this one. Let me know what you think. And yeah, you could watch me solve it live during the contest now. Okay. Maximum points after collecting coins from all node. There's a tree, edges, number of coins in vertex I, and an integer k. Okay, I mean that's fine. Starting from the root, you have to collect all the coins such that all the coins can be collected if the coins of its end. So okay, what does that mean? Okay, so 0, 1, 2, 3, 4. We have a linked list with 10, 10, 3, 5. What is even k? Oh, I guess I have to keep reading. Can we? I missed the collection part. This is why I'm doing really poorly on contests. I literally didn't even read this part. I don't know why. All right, collect all the coins, but you will lose coins. Okay, that makes sense. So just collect all the coins, but you get points. Okay. All the nodes j present in a subtree of nodes in I. Okay, so you could either take half the coin or coin minus k or something. And if you take half the coins for points in the recursion, you will go there. Okay. Do we always start at 0? Starting from the root, but what is the root? Is the root always 0? Does it tell you? Oh, it does tell you on the first one. Okay. So you start the root, you can recursively either do this or that. Is it memorization? It's just memorization, right? It's just a number of things. And what is it? Coin supply is 10 to 4, so that means that you can memorize after, what is it? 10 to the, what is 10 to the 4? 10,000? 10,000, that's 2 to the 15 or something? I don't know. Man, I am really bad at math. Would I say 10 to the 4th? Right, so like 2 to the 13? 2 to the 14? 2 to the 14 is 16,000. So that means that after that many iterations, so it's 14 times nodes, which should be good enough, right? Am I missing something obvious? Are people already done with the contest? 2 people are, and I can understand why. All right. Yeah, I don't know if I'm misunderstanding something, to be honest. But okay, let's set it up. Right, and then we just do recursion. Let's go. The node and used, say. I also want the parent, but I don't want to cache on it. I guess it doesn't matter. The parent it will always be the same. Watch Leetcode just be silly anyway. Right, so then now total is equal to 0, right? That's the total number of points. And basically we really only have 2 things to do, right? So, oh wait, well, we have to collect it, and then yeah, like I said, only 2 things to do. So basically we can either collect it on the k way, right? And then so the k way is go oh yeah, and also if used is greater than 14, used is equal to 14, say. Well, yeah. Okay, yeah. And then so basically now we take the k way, right? So tick is equal to coin sub node minus k, and we lose points anyway, so okay, so we don't even have to do anything funky. And then for we in ye of node, if we is not parent, then tick we add go we node used. We haven't used anything, so then now, yeah, and then actually it will just be max tick and half, say, and half is just equal to coin sub node divided by 2, right? I'm using the right shift for whatever reason. Or oh, and I have to take track of used. So this is coin is equal to coin sub node already, right? So this is coin. So from the previous thing, and then now half is equal to right? And then for we and ye of node, if we is not parent, have to do we node used +1, and then that's it. Right? (11 and 16). The timing seems okay. Let's give it a submit. I mean, maybe I have a silly mistake, but should be fast enough. Yeah, I guess I should have done it during this contest. I mean, that was. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.